So here we have a problem. It says given that A, the matrix, is 1, 2, 3, 4, and B, the matrix, is 5, 6, find AB, right? Find AB. Before you begin to multiply, and how do I know that they're multiplying? Because A is hitched up upon B. So once you see them hitch up, you don't know, say, them multiply together. So before we multiply matrices, you want to check to see that it's conformable. You remember what conformable means on previous videos? So you need to check the order to make sure that multiplication can work. So the order for A, number of rows by column, it has 1, 2 rows and 2 columns. 1, 2. So A is a 2 by 2 matrix. Let's look at B. It has 2 rows, 1, 2, and 1 column. So it's a 2 by 1 matrix. To check whether it's conformable, the number of columns in the first matrix, because we're dealing with A and then B, the number of columns in the first matrix must be the same as the number of rows in the second matrix. Now look, we're comparing this with this. Are they the same? Yes, they're equal. So once the number of columns in the first matrix is equal to the number of rows in the second matrix, then they are conformable, which means we can go ahead and multiply them. If they are not conformable, then you can't multiply them. The product does not exist. Now this is what is interesting. Whatever is left from the order, which is this and this will be the order of your answer. And just do that and go like this. The order of product. Good. So that means AB is supposed to be a 2 by 1 matrix. So let's go ahead and see how this works. So I have A. We're going to multiply it by B. Oi, too much. So A is 1, 2, 3, 4. And B is 5, 6. Now, when we're multiplying matrices, there's a particular order in which we multiply. We multiply row by column. I'm going to show you what that means. And that is why I like using crayons when I'm doing this, because you can clearly see what you're dealing with. So we're going to do row, right? That's the row. And I'm multiplying it by the next column in the next matrix. So my first entry, row by column, I'm going to do 1 times 5, and I'm going to add that to 2 times 6. You see what happened a while ago? So the row by the column. So when I'm finished with that, I move on to the next row, which is this row, and I'm going by this column. So it's going to be 3 times 5 plus 4 times 6. I don't have anything else to multiply, so that's it. So I'm going to simply work these out now. So 1 times 5 is 5, and I'm going to add to that 2 times 6, which is 12. So this will give me 17. Then 3 times 5, that's 15, plus 4 times 6, which is 24. And that will give me 9 at the end, 39. So when I'm finished, AB is going to be 17, 39. Simple, not true? We're I'm going to work some more complex examples. So here we have another question, and it says, given that X is this matrix and Y is this matrix, we should find X, Y. And this means we're going to multiply the matrix X with the matrix Y. But first we need to check if they are conformable. So the order of matrix X is a 2 by 2. And the order of matrix Y is a 2 by 3. Because 2 rows and 1, 2, 3 columns. And we're checking to see if they're conformable. So I'm looking at the number of columns in the first matrix and the number of rows in the second matrix. And because they're equal, that means multiplication for these matrices can work. And my resulting matrix is supposed to be a 2 by 3 matrix. So let's get into it. So I'm doing X by Y, and X was 2, 1, 0, negative 1, and Y was 1, negative 1, 0, 4, 3, and 0. And remember, when we're multiplying matrices, we multiply row by column. Good. So this is telling me 2 times 1, and then I'm going to add 1. So I'm going to add 1 times negative 1. Good. So I'm finished with this row and this column. So I'm going to do this row with this column now. So that means I'm going to move to my next element in the first row. So 2 and the 0 will come next. So I'm going to have 2 times 0, and I'm going to add to that 1 times 4. See? So I'm finished with this row and this column. So I'm going to have to move to the next column here. I will multiply row by column with matrices. So that means I need to go over some more. So I'm going to go 2 with 3, 2 times 3. And I'm going to add to that 1 times 0. Good. So now that I'm finished with this row by all of these columns, I need to do this row down here, so by all of these columns. So I'm going to come now and say 0 by 1, 0 by 1. And then I'm going to add to that negative 1 times negative 1. If you notice, I'm repeating this element here and here with this one here and here. So if I'm going to follow that pattern, I should see 0 here, 4 here, 3 here, and 0 here. But let us do it to ensure. So I'm at this second row now with this second column. So 0 times 0. And I'm adding to that negative 1 times 4. So I'm taking my time going through. It takes a little time, but it can be done. So notice this 0 is being repeated here. This 4 is being repeated here. So we're finished with this row and this column. We're going to move to this row and this column. So I'm expecting to see 3 here and 0 here. So I'm checking as I'm going along. So it's going to be 0 times 3 plus negative 1 times 0. And then I'm just going to close off my brackets, my matrix. So this now becomes my working matrix. So I'm going to take my time and work out each part and then small it down. It's a little bit of work, but it can be done. So 2 times 1, that is 2. And I'm adding to that 1 times -1, which is -1. Putting them in brackets to help me. Right? So 2 plus -1, which really means 2 take away 1. That's 1. Good. So I know that the element to come here is going to be 1. Take your time with me. 0 times 1 is 0. And I'm adding. Negative times negative give me a positive. 1 times 1 is 1. So this is really 0 plus 1, which is 1. See that so far? Take your time with me. I'm just going to take my time and go through. Go over some more. 2 times 0, 0. Plus 1 times 4, 4. 0 plus 4, 4. So 4 comes right here. See? Take your time and just do the little thing. 0 times 0, 0. Negative times positive is negative. 1 times 4 is 4. And you're adding them. This is simply saying 0 take away 4, which is -4. Just as simply go through. So now 2 times 3 is 6. Plus 1 times 0 is not 1 but 0. 6 plus 0 is 6. So I'll go and put 6 here. Alright, 0 times 3, 0. Plus -1 times 0, 0. So this becomes 0. 0. Close my bracket. So after multiplying x by y, I ended up with this matrix. 1, 4, 6, 1, -4, 0. So this is what xy is. X times y is this matrix. Interestingly, I think I want us to find yx. So I want us to find now y by x. You think it's gonna be the same thing? Well, we don't know, we just have to check it out. So this time it says y times x. So the matrix y is going to come first. So it's going to be 1, -1, 0, 4, 3, 0. And then we're going to have x, which is 2, 0, 1, -1. Remember, the first thing you must check before you start multiplying anything, you must check to see if it's conformable. So the order for this matrix is 2 rows by 1, 2, 3 columns. And this one is 1, 2 rows by 1, 2 columns. Let's check if they're conformable. Column in the number of columns in the first matrix, number of rows in the second matrix. Seeing that 3 is not equal to 2, then the product yx does not exist. That means you can't work it out. You can't go no further than that. So this is to show that the order when you're multiplying and when you're adding and subtracting, the order for matrices, it matters. So if I say to you xy, work out x first and then y. Don't just mix it up because you feel like you want to mix it up, because you can mix it up. If you do it that way, they will get it wrong. So the order matters. We just proved it. So xy is this matrix, and we were trying to do yx. We end up with something we can't really work out. So the order when you're multiplying, adding, subtracting, it does matter.